In this video, we showcase MC-RAG, a new structure-driven RAG system. As far as we know, it's the first RAG framework that can accurately fulfill every constraint in a user's query. This system reformulates the retrieval process as a subgraph matching problem on a knowledge graph to achieve structure-aware and constraint-consistent generation. MC-RAG system consists of three main modules: iterative question answering for retrieving knowledge that satisfies all query constraints, and visualizing the reasoning and answer generation process; knowledge graph construction for transforming unstructured text into structure; knowledge graph visualization for constructing and displaying the external knowledge index. Now, let's demonstrate the core functionalities of the system. Firstly, user can select a or more relevant knowledge bases and inputs a question using natural language. For example, which disease commonly uses massage as an adjuvant therapy, is prone to have adrenal incidentuloma and hypertension, and requires differential diagnosis from subclinical Cushing's syndrome, adrenal incidental often lead to hypertension. MC-RAG will automatically model the input question into query graph by identifying its underlying semantic constraints, such as recurrent conditions related to disease's treatment symptoms, differential diagnosis for constructing a corresponding query subgraph that formally represents these constraints by nodes relationship. It then performs graph exact matching via isomorphism or approximate matching within the knowledge graph to identify fact fragments that correspond to the query and fulfill all specified constraints. Finally, these match subgraphs with corresponding contents after a designed three-stage generation strategy are provided to a large language model to augment the generation of a natural language answer. MC-RAG ensures that each constraint is strictly satisfied effectively, avoiding the common issues of information omission and hallucination observed in traditional systems. For the above question, the system ultimately produces the answer: type 2 diabetes. This system can clearly show the breakdown of each constraint in the query and how well each one is satisfied in the actual results. For comparison, we asked the same question to ChatGPT-5. As you can see, its response doesn't meet all the semantic constraints, lacking the relationship between adrenal incidentuloma and hypertension, so the answer ends up being inaccurate to be primary aldosteronism. Next, I will demonstrate the process of knowledge graph construction. Users can upload all kinds of documents, from academic papers to policy files and corporate reports across any domain. MC-RAG system automatically performs text segmentation, entity recognition, and relation extraction, ultimately generating structured knowledge graphs, and then construct a asterisk tree index. Once the final index is built, the system offers a visual interface that presents its structure. Nodes represent entities, and edges indicate the semantic relationships between them. Users can freely zoom, drag, and click on nodes to explore the corresponding entity attributes and related information. This interactive visualization enables users to enjoy the way understand the structure of the knowledge and the semantic connections for verifying answers. Finally, we evaluate MC system on a large real dataset containing approximately 120 or multi-constraint queries across 20 domains, each query involving an average of 4.6 constraints. Experimental results show that MC-RAG significantly outperforms representative state-of-the-art RAG, and LLMs from 34% to over 543% across all evaluation metrics. These two figures show the system's efficiency comparison. MC-RAG achieves significant accuracy without introducing much additional time cost for both offline and online. Thank you for your attention.